Good afternoon, everybody. I think I can speak in English, but anyway, we have the translation for those who might need the translation, or feel free to speak in both languages. We've had a long day today, and I think there were interesting discussions. As you know, the theme of the ministerial session in UNESCWA is about the role of technology in achieving sustainable development. Now, some of you have been with us in the launching of the Arab Climate Change Assessment Report, and even in the process of working on the reports, I should say, because there are more than 11 reports, technical notes, scientific notes, and the important thing about it is really it has invested in a lot of the technology and the sciences, and has linked them in many ways directly to the assessment of looking at the impact of climate change, and then the so what. Okay, we have changes, increase in temperature expected. We've observed trends in increase in temperature, change in precipitation, but then so what? What is the implication on water, on the hydrological model, on the hydrology, on specific basins, on productive sectors, on food, etc. This process has been really a cumulative process in learning about climate change and the complexity of climate change. And as we know, those of you who were in the session yesterday, we've been making the point that climate change is not just an environmental issue. It is everything. It is about it's about policy, it's about investment, it's about adaptive capacity of people and sectors, it's about land, it's about urbanization, it's really about everything. So today in that side event, although we have launched the report, and I'm really happy to see that the downloads on the reports have been very quite impressive. Today's session, we will zoom in on one area, which is how have we used technology in terms of modeling, in terms of GIS, to reach the results, and then the so what factor. What are we using this not just the technology, but what does that mean in terms of planning, in terms of assessment, etc. And then the next stage, what has this project, the RICAR, known as the RICAR project, the Regional Initiative on Climate Change in the Arab region, where are the next steps? And it has already, we've had a very interesting initial discussion of where we want to go with the areas, and then we will be hearing from colleagues on this impact. We will also be hearing, and I hope people from member countries, how this has been useful to them or not so useful. How was it? Was it user-friendly? How could they download the information from the modeling, and how were they able to downscale it to a national level, to a basin level? How easy was it, and what we could do to make it more useful in the future? So we have Carol, who will be our colleague, Carol Sherfain. She is she's the chief of the water resource section. She will be presenting the project, the RICAR, the initiative, and then we have Ihab Janad, who is from Aksad. He's the leading scientist in Aksad. He has been a partner of the whole process, and I think I can safely claim the knowledge behind the modeling exercise or the GIS and the assessment report. And then Carol will come back to say what is expected in RICAR 2, if I can call it RICAR 2, or in the next step. And then I'd like to hear from all of you if you have been familiar with the process or you want to ask questions about it. Carol, please, the floor is yours.
Thank you very much, Rhoda. Welcome, everyone. I'll try to go again, for those who are not familiar with the RICAR process, give you a little context to also then lead some of the outputs and showing how we've drawn on technology. But to go back to the focus of this session, which is science policy interface and how we are using climate modeling outputs, and not only climate modeling, but hydrological outputs and vulnerability assessment to inform various policy frameworks and the work of intergovernmental organizations. And actually the call for this came exactly just over 10 years ago. In 2007 was the first time in this Arab region that we said in a regional statement that climate change even exists. So just think about this. In 2007, December, was the first time the Council of Arab Ministers for Environment came together and said, we have to address climate change. We've come a long way right from there, with now having an assessment report of what climate change means for a region. And what we can see from that is basically 10 years after, we have now generated a science base not only regionally but nationally in a lot of your countries going forward. And this is not only influencing what is traditionally thought as the environmental domain, but a whole range from foreign affairs to planning, economics, water, agriculture, etc. So when we set up RICAR back in 2008, actually in response to this mandate, they asked us to make an assessment. It is really a science tool. There's no policy associated with RICAR. It is the scientific basis to see how fresh water is impacted by climate change and what that means for socioeconomic vulnerability. And we did this in order to inform different processes, but RICAR itself is only the science. And we did this through a very collective partnership orientation under the auspices of the Arab Ministerial Water Council, but with 11 partner organizations. Because if you don't have a common understanding of the science, you can't lead measures and policies and plans that are coherent. So we are very pleased to have all these partners also involved in this work. In terms of our pillars, the core was the integrated assessment, but it is framed in a regional knowledge hub. There was a lot of capacity building and institutional strengthening and awareness raising in this process. To go to the meat, the integrated assessment is unique. What you see in international reports about climate change is normally the outputs of global climate models. Okay, what they do in terms of estimating before at a scale of 300 kilometers square what the impact of climate change is, down to now a much more sophisticated, maybe 50 or so. With the improvements of technology over time, we can get a finer resolution of those outputs. But even when we started, there was nothing for this Arab domain, so we couldn't use global climate modeling outputs. We had to create a regional model that allowed us to work at the Arab domain. And so we took this regional climate modeling for outputs, but that was not enough because we want to work about water, and water influences flooding, agriculture, cities, etc. We put that into two regional hydrological modeling, and we took those impacts and outputs into a vulnerability assessment. And in order to do that, it's really converting also from the technology side, which is the theme of the session, bringing NetCDF, Fortran language, a lot of outputs from computer science, and putting something that's more accessible like ArcGIS to allow us to make an integrated assessment with various layers that we can use, and you'll be hearing more about. But just a little bit more on the science. Before 2010, there was no Arab consciousness in the global climate arena. It did not exist. It was Africa, it was Asia, it was Europe. There was not a Mediterranean, there was no Arab. So we had to create a scientifically validated and vetted Arab domain through which we can do climate modeling outputs. And this was done through a collaborative process. And as you can see, this area is much larger than the Arab countries because we want to talk about water. So what does climate change mean for the headwaters of the Tigris River Euphrates, the headwaters of the Nile, for all the pressures coming off the Indian Ocean to Oman and Yemen? These have to be considered in that regional model, so it's a much larger framework than what you might think of just a country, let's say Egypt just doing a model or Sudan. It has all those pressures coming in a coherent way so that Morocco and Oman can speak on a common basis, common scenarios, and common way of thinking when they look forward. And this is just to prove how badly the global community looks at us as an Arab region. This is back in 2010. We're divided in 5 different boxes. That's how the IPCC reports. After that, they tried to improve a bit. It's 3 different boxes. There were no outputs that allow us to speak coherently, and that's what RICAR does for you. So that is why we have this large Arab domain. Because of politics, it's called the MENA domain, but this is how we do our climate modeling. What we also did, we looked at scenarios that were internationally vetted. So under the IPCC, the Intergovernmental Panel on Climate Change, they agreed on scenarios in the last report that would help estimate what the impacts of climate change would be. How to estimate climate change impacts from now until the end of the century. And basically, what was agreed to in the global community to look at standard scenarios under this coordinated experiment, and there was RCP 4.5, which is showing an increase in emissions and then leveling out by the end of the century, and then a more negative, more, quite honestly, business as usual scenario that says emissions will continue, and that nothing we're going to do on mitigation will help, and this would happen. We decided to take this, let's say, worst case, high-end scenario and moderate, so that we would know if nothing changed, what would that mean? So when you look at the modeling outputs in the book that you have in front of you as the highlights, but you see the red, which is that worst case scenario, and that moderate yellows, which is the midpoint scenarios. And that's how you can sort of see how you want to interpret, if you have mitigation, what can happen for impacts in that regard. One of the things we had a lot of training on and awareness raising is that you can't do this once. It's not just running one model one time and getting one result. This is forecasting to the future 100 years, okay? And to do that, you have to have a range of baseline that goes from 1950, and you're estimating at 3-hour time intervals what is happening until the end of the century. You have to do this several times and then figure out what these projections give you in terms of a range of uncertainty. And that's where that high computing power, that science can be used to help moderate and better understand and quantify the risks of uncertainty associated with these projections. The more projections you do, the better you have an understanding of the future. And there's a series of projections we did, and we are continuing to work on this in the future. So that's the climate modeling output, but we did not only take the climate modeling, we linked that to hydrological modeling, which means taking out these outputs, which we generated at a 50-kilometer scale mostly, and then putting them into 3 hydrological modeling, and then extracting indicators of most concerns, such as extreme events indicators, that help with drought and floods, etc. And then this goes into a vulnerability assessment that you will hear more about shortly. Basically, all the work that the IPCC tends to think about, all the impact assessment, is just this part of a vulnerability assessment. The socioeconomics mean, what does this mean for wealth? How does wealth influence, or literacy, or education, or stability, or governance? How does that influence your ability to deal with these impacts? Because even if we find temperature increases across the region 5 degrees by the end of the century for everyone, the ability of Dubai to cope is quite different from Palestine's ability to cope, or Somalia, or Morocco, even if the impact is the same. So that is where a vulnerability assessment becomes quite different from an impact assessment. And the global community tends to think of impacts. Even though they say vulnerability, it tends to be a biophysical story versus a socioeconomic. And that is the value added also of this work. A lot of capacity building and training, and you can find all this on our hub. Just to go quickly towards the end, before I turn to my colleague, the report that you have here was launched in September. We were very pleased to have several ministers with us and director generals for this launching, and all the partners. Not only was this report launched, but a whole publication series, which is available on the internet. You have case studies on climate, not only climate, but agriculture, water, health, extreme events that are produced by the partners, creating a cohesive series of outputs for your availability, as well as technical notes for the scientists among you, and training manuals. And this has already generated more material on adaptation, which is also available, and some copies are here. And what we had inside the report, therefore, is a whole component on the impact assessment findings, and then a whole component on the integrated assessment findings. And you have basically hundreds of maps available at your disposal in PDF, and all the other variations that I'll show you later that show you what the changes over time means. This is a baseline. This is how much hotter it will get under the moderate scenario. See how it's the moderate scenario, mid, and how much hotter it gets. In the high-end scenario, that 8.5, look how much redder we are compared to before. We're talking 5 degrees higher, basically, for the region by the end of the century. And if you have AC, that's good, but what if you're working outside on some new sports stadium in Qatar? Or what if you're a woman working in the fields in Morocco? This has a lot of implications for a lot of dimensions. Same with precipitation. You're seeing changes in various parts of the region. Look how much drier it is getting when you go up to, let's say, the Tigris and Euphrates. All the information is again there. I'm just highlighting what you have. Extreme events, very important to think about this, because when it's not only a peak time in temperature, if it's very hot for 1 minute in the middle of the day, that's very different from that same temperature of 56 degrees being the same for 5 consecutive weeks or 3 consecutive weeks. So a lot of these extreme indices allow us to quantify and see trends and analyze what that means into the future. I'd like to say, and I'd like to highlight with our colleague Aksad, we convinced the World Meteorological Organization to talk about summer days over 40 degrees Celsius. It doesn't exist in the global community. They don't think about over 40 degrees Celsius. They only think about over 35 is the hottest they get. Here it's normal to have 56-degree days at some points of the summer. So this is something that's very region-specific that no one else was talking about and that we have to talk about. Extreme events indicators that are available, hydrological modeling outputs that this informed, and then I want to turn it over to my colleague to give you a little bit more here, but basically you have hydrological outputs at the regional level. You have, I'm sorry, it's not going forward. You have sub-domain analysis for some of the shared basins, for those who really do like water in the room, seeing how certain areas are specifically sensitive in the shared basins, water basins in our region, and hydrological outputs for that, and then how this affects the vulnerability that links all those components together. And that's where I will turn to my colleague to talk to you a little bit more about those outputs related to the vulnerability. So here we are.
So thank you,
Yeah.
Carol. We'll be coming back
Yes.
to you with the next stage,
Yes.
next steps
we go.
of RICAR, what we are planning and what we're talking about. Ihab, the floor is yours. We have Ihab
Thank you.
Janad, who will be talking about the use of geographic information system to undertake vulnerability assessment. Please go ahead. Ihab.
Okay, thank you very much. Of course, we were very pleased at ACSAT to be very close partner with UNESCWA and the other 10 partner. We worked for almost 10 years with RICAR and the hydrological and the climate modeling and the vulnerability. I would like to just to focus on something Carol mentioned about the importance of the output of RICAR. This is the first time in our region to have climate change daily data. Daily data is very important for any impact study. If you want to do impact study on water, on agriculture, you need daily data. So for the first time in because IPCC did not provide such daily data. So this, I mean, very important to mention that this data will be available for everybody through the Knowledge Hub Carol will talk about later. So now I will talk about vulnerability. How we raise it on? Raise it on.
What happened to this cursor? Sorry, it's just. What happened to Hadi? It's showing on top but not on the screen. Resume. Here, resume. Resume. Resume slideshow. I'm sorry. There we go.
Okay, go back. Okay. And واحد go back. Okay, so I mean, the RICAR includes the regional climate modeling, then the hydrological modeling, then we use the output of this hydrological modeling and climate modeling to do the vulnerability assessment. Sorry, because this
Yeah, it's
Not
not
my-
clicking up.
Okay, so The vulnerability, I mean, the major component are the exposure and sensitivity, and both of them, aggregation of exposure and sensitivity came with a potential impact. Then we have the adaptive capacity with potential impact, we get to the vulnerability. So this is the major component of the vulnerability assessment. We had 5 sectors, main sector. I mean, it was the water, biodiversity, agriculture, infrastructure, and people. And we have 9 subsectors included in this assessment. The first step was to select the indicator included in this assessment. And this really was very lengthy and complicated procedure. We had vulnerability group, which had experts from most of the country and main institution in the region. And it took a long time to decide on this indicator for different components. It was about 68, I guess, indicator at the end. And after that, of course, we developed the impact chain. For every subsector and for every sector, we have this impact chain, which, I mean, the impact chain includes the indicator for every component of the vulnerability. The difficult things after that to collect the data for this indicator. Of course, one major challenge was any indicator must have data for the whole region. I mean, the data must be available for the whole region, which was a major challenge. Of course, the exposure component, this was the easiest one because all indicator, the data was from RECAR output, from the hydrological and the climate. So this was already available from RECAR. But for sensitivity, of course, we have to rely a lot on international and database and global database available to use this data in the indicator. Of course, we get some data from UNESCWA, from ACSAD, we have some map from FAO and other organizations. And for adaptive capacity, this also one of the difficulty for adaptive capacity is that the data for this, most of the indicator was available only on country level. It was not spatially distributed. So this also raised some difficulty, and most of the data was from UN database. After we collect the data, we have to do a lot of preparation for this. It was not ready, I mean, in the final format. So we use heavily, we use the GIS software to prepare this map. And I will mention only 1 or 2 examples to show you how, for example, when we want to find the watering area for livestock, we have to go through what's the water demand for different livestock. And after that, I mean, we got the livestock density. And then we develop, based on that, what's the watering area for different livestock. So all this procedure was done using the ArcGIS software to reach to this final map for the livestock. Of course, we prepare the map with a certain format. We have all the required format for the map. After that, I mean, we cannot do aggregation with the real value. So we have to transfer all actual data. We had to do that to unitless data. So we selected scale from 1 to 10, and we have to do normalization. So all the cell must have number from 1 to 10 only, not the real value. For example, I mean, this is the rainfall map. Here we have the actual value. Then we have the classes from 1 to 10. I mean, so all the map, it has to be reclassified. Some of them has numerical value. This was not difficult. But some of the map, like the land use map, this does not have a numerical value. So really, the only way to reclassify, we have expert opinion. I mean, so we have a group of people, and we did this in, taking different opinion, decide on the reclassification. So we have to do this for all developed map. Of course, there is a lot of things in between. I am not going in detail. So we did the weighing procedure. We have to do questionnaire and other things. The final stage was to do the aggregation. And there is different method to do aggregation. We select to use the geometric aggregation. So, and this was done on different level. I mean, first done on the component level, then on in between component, so between exposure and sensitivity to get potential impact, then with the adaptive capacity to get to the vulnerability. So, I mean, of course, in every component we have several layers. For every indicator, the layer means the map, raster, and one important, several map, at the beginning it has several resolution. So we have to unify this, all of the map should have similar resolution, so we have to do that using the ArcGIS. Then we did the aggregation. Of course, all the aggregation, all the mathematical, this equation was used, I mean, this done with raster calculator within the GIS environment. And I will just go very quick about some of the, I will not go in detail for all 9 subsectors, just I will focus on water. And so for water, for example, the area, I mean, covered, it was almost 50% of the Arab region, included, I mean, populated area, irrigated area, livestock area, forest and wetland area. This is the impact chain for this sector. Of course, for exposure includes the temperature and precipitation, runoff, and some of the extreme, I guess, here. Then for sensitivity, include the irrigated area, the population density, and rainfed area, etc. For adaptive capacity, I mean, here, I mean, mostly it was economic and social indicator. So this result of the aggregation of the exposure indicator, and we can see, I mean, most the exposure which is related to the climate change, and we can see most of the region has moderate exposure. And this is the sensitivity, and we can look to the table, and the green color has low sensitivity, and the red has high sensitivity. Most of the region has moderate to low sensitivity. Then, of course, we aggregate the exposure and sensitivity to get the potential impact. And as Carol mentioned, I mean, the potential impact does not include the socioeconomic factor. So this more, I mean, about the climate and the sensitivity. And we can see that the red one has high potential impact, and the green has low. And most, if you look to the table here, for different, of course, here we have different scenario, 4.5 and 8.5, and 2 time period, mid-century and end century. Most of the area has moderate potential impact. Of course, this adaptive capacity, and really bit scary. You can look, I mean, that the red mean the area has low potential impact, and we can see, low adaptive capacity, and you can see, I mean, 40% of the region has low and 50% moderate. Only 4% has high adaptive capacity. And we found out, I mean, that the vulnerability influenced a lot. I mean, the main influence factor was the adaptive capacity. So when we aggregate the potential impact with adaptive capacity, this is what we get for the vulnerability for water. I mean, this for availability of water. And you can see, I mean, of course, the red has high vulnerability and the green low. There's no green almost, I mean, almost there is no green, I mean. So most of the area has moderate to high vulnerability. It is high, which is, I mean, really tell a lot of message, I mean. And the most vulnerable area is the upper Nile River and the southwestern Arabian Peninsula. And this is really very important result, I mean, for decision maker. I mean, we need to look to this area with high vulnerability. Of course, I'm not sure here, but we have some map for hotspot area. For water available for a crop, we looked mainly to rain-fed area and irrigated area. So, and the total area was about 22% of the total Arab area of Arab region. This is the impacted chain. I will not go in detail. And this is the exposure. It's similar because most of the sector has similar exposure, but sensitivity we can see here. There is the area sensitive is mostly it is in the lower Nile, where is the Delta River and the Euphrates Basin, and Morocco and Tunisia area. So 66% has moderate sensitivity. I will go directly to the vulnerability area. This for water available for agriculture. See, also about 84% for the worst scenario RCB 8.5 at the 84% of the agriculture area has high vulnerability. The water available for agriculture, which of course, also most of the area between moderate to high vulnerability and mainly high vulnerability. And this is a vulnerability, is a hotspot for water available for agriculture. The last one I will show is the inland flooding, which is not too bad. The result not similar to the water. And so the idea at the beginning was to look to the sea level rise and inland flooding, but for some technical reason we not include the sea level rise. We include only the inland flooding. And of course, here in the exposure, we had some extreme event. I mean, because this is important for the inland flooding. And this is a map of the exposure. And we can see most of the exposure is moderate to high. I will just go to the vulnerability map. I guess this is the vulnerability map. We can see about 90% of the study area has moderate vulnerability. I mean, we don't, the high vulnerability only 7%. You cannot see a lot of red because most of the vulnerable area is in the Wadi system, which represents small area. I mean, therefore you cannot see it here similar to other map. And thank you very much.
Thank you, Ihab. Before I give the floor to Carol again to take us into the next stage and maybe ask the questions of we all ask the so what factor. We hear about there's going to be a temperature rise of 5 degrees by 2100, but then there is a big so what factor. What does it mean for us? And sometimes even immediately, I don't think we need to wait for 2100. I'll open the floor for any, if you have any questions of clarifications or comments before I give the floor to Carol. Sir, please. The representative of Sudan and the big partner of the RICAR process.
I hope so. Thank you very much. I'm very proud and happy that we have a framework for climate modeling for the Arab region. This is the biggest step. Because unless we have this framework and task force and people, then everything is silos. And climate had never been able to have better results with silos, because it is a global or maybe regional phenomena, the climate. It does not need a visa or will be regulated by local interventions. To start from a point where Carol said we will not be running it once. And this is the key factor, that the effort should go now open for the framework to be used by different parties and to be enriched by different parties. opening it we need the technology again. We need to use cloud computing. We need to link it with big data. Big data is available here and there. So how we link this all, then we'll, on the same wavelengths, let me switch to in the second presentation, we have seen as an example, we need this amount of water for cattle. We need this amount of water for crop per year. But it's not like that only. This amount should be distributed around. So how can we go to the time scale, the refined time scale? Because if the water will not come for 2 months in Somalia, 5-6 million of sheep will die. And if for 15 days the rain will not come in Sudan for the sorghum, then the sorghum will die. So how can this can be refined, connecting it to actual weather data, so that weather forecasting can work on the climate, to be linked to the climate model, the big one. And then I come to the so what and what to do next. How mitigations that we are planning will affect the result. How this can be shown to policymakers, and then we tell them, okay, let us plant 100 billion tree, distributed this and that and that, and then this will change the picture to that. Will reduce temperature 3 degrees or 5 degrees, and all these scenarios. So running the scenarios, the different scenarios, futuristic scenarios, on the model, then will show us how effective they are. If I can move a bit from the body of the report to other relevant issues of how green technology will affect the climate. And this can be used then in the mitigation later on. And especially emerging technologies and frontier technologies, which was one of the subjects of this session. Nanotechnology is now doing a lot into water efficiency in crops and for purification, for Internet of Things, and smart agriculture is doing a lot in water management, into proper and better agricultural processes. So we come linking, like I have seen here, the GIS modeling with the climate modeling, with the needs. Then we will have a geospatial sustainable development map, where we will have the climate modeling in the heart of it, and then all the other factors affecting, showing here and there. And then even we can go later on into other models of economical models and poverty models and other linked models. So I'm very happy. I don't want to take much time, but I'm very happy that we have a base to build on now. So how can this go on? And then I am very happy also because researchers will have a real subject to work on. In all our universities, they can have real subject to work on rather than having an invented or created problems. Thank you very much.
Thank you. I think it sounds like as if you were with us in discussing the phase 2 of the RICAR project, and I think Carol will touch on some of these issues. We have AUB, and then I would like also to ask Leah, who has been, Leah works for the with UNDP for the Ministry of Environment, and she's a negotiator, and she has used the model. I would like you also to tell us, but doctor from AUB, please go ahead. Dr. Mahika.
Okay. I'm Dr. Mazen Tamer. I'm a professor in biotechnology, a part-time lecturer in AUB. First of all, I'd like to thank you for inviting me to this round table. And I've noticed that there was a lot of work that was integrated in the body of that RICAR report. Quite impressive. From my point of view, I just focused on few agricultural aspects, so the chapter relating to agriculture. And, well, I've noticed that, first of all, RICAR 1 has made a good contribution in relating water to agricultural productivity, crop productivity, domestically here in UNESCWA countries. However, I look very much forward that, and this is a recommendation to the ministerial declaration and to the final report, that RICAR 2 includes crop yield as a indicator, as an indicator, sensitivity indicator, in addition to the 10 indicators that were chosen. So that's from a general point of view concerning the report. I was also, I took note on page 176 of the report, chapter 6, so that's 6.3. I believe, yes, 6.5, the impact of on selected crops in Egypt, Lebanon, and Jordan. And I believe that FAO used, I think, used a simulation called Aqua Crop. Yeah? So to simulate, it's a nice game. So to simulate the effect of climate change on crop productivity, yeah, and a major conclusion in this report with huge impact was given here, which is C3 crops, let's say wheat, versus C4 crops, sorghum. So wheat may benefit from an increase in CO2, actually, but not sorghum. I teach plant physiology, and my question, if anyone here knows, what are the parameters that were used by aqua crop? It's interesting. Does anyone know? Do you know, Carol, or Mr. Ihab? Yeah. May I have an answer, please?
Yeah, we'll leave the answers for later. Let me take a round of comments or questions.
Thank you very much.
Thank you, Mazen. Leah, please go ahead.
Yes. Good afternoon, everyone. Also, thank you for inviting us to be part of this session. Just as my colleague just said, we are really proud to have been partners in the development of the RICAR outputs. And from a national point of view, from our personal point of view with RICAR, it was indeed a tool that was highly used and mainstreamed in our climate change work in Lebanon. For our third national communication, I think you're all familiar with this tool that every country has to report its greenhouse gas emission, but also its impact assessment of climate change to the convention. And we really, usually governments spend a lot of money to prepare this national communication, and specifically the vulnerability part. And RICAR was definitely a vehicle for us, not only they did the job for us, actually, for all the countries on the table, but it was able to provide a more accurate result than what we have presented in the second national communication and the initial national communication. And this first allowed us to gear resources to other more needy subjects and more vulnerable areas. But also, we discovered that, at least for Lebanon, the situation is not as bad as we have expected. So now we have different results. we have we have more moderate results for what will happen in Lebanon. And this has been used in informing our policy-making process and in adapting our adaptation policies to these new results. And this brought us to really a new era of thinking about adaptation, thinking about priority sectors, and taking this into account. It also helped us in negotiations, as you said, Rula. We participate in negotiations, and vulnerability and adaptation is a big issue in adaptation. And the RICAR definitely gave us the tools and the needed information to make a more informed decision making, whether it's from our position as a country or our position as the League of Arab States. So finally, we had a common denominator where we can start from. Finally, for RICAR 2, I'm not sure if now is the time to talk about RICAR 2, but I've just, I just heard that there is RICAR 2, and we are really looking forward to this new phase. Please keep up the good coordination work. I think the main success of RICAR is that it was a bottom-up approach. We have all been involved in the good and in the bad, and this gives really ownership of these outputs to every one of us. So thank you for that. We hope that this integration will still be part of RICAR 2, and we are looking really forward to working in this next phase.
Thank you, Leah. I don't know if colleagues from Iraq, Oman or Jordan, because we've been talking on bilateral basis, but maybe you don't want to intervene or say how this, okay, maybe I can then say we've been talking on bilateral basis to see how we can take the results of RICAR and downscale it to look at the basin level, for example, in Iraq, in terms of water, surface and groundwater, or even the food security, which is part of the reconstruction plan in the case of Iraq. I don't know if our colleague from Oman or from Jordan, you want to add something, how this could be useful to you? Please, تفضل.
Yeah, thanks. Again, good afternoon, everybody. Actually, it's very interesting, actually, and thanks to UNESCWA, actually, for organizing this side events. And no doubt, actually, it's very comprehensive study, actually, as the colleague from the Sustainable Development Division presented. And specifically, actually, I will talk about water, and no doubt, water resources is very important when we come, to study the impacts of climate change on water resources specifically. And so, there are many. Actually, I'm aware of some kind of vulnerability studies, and and also the data. And the question is as the colleague from AXAD said, they come with huge data, and that's really what we want in Arab region, because when we study actually the climate change and effects on water resources or food security or agriculture and other sectors, we need some kind of huge data. So this is a question actually, for example, the temperatures, to which, how many years you used for the precipitation also. And also, have you looked to other methodologies? Because I know, UNIB, for example, they worked with the University of, in China. They came up with different methodologies for studying vulnerability. And I used actually that in Oman. So they use the same classification. From 0 to 1, using different methods. They talk about also the adaptive capacity, the sensitivity, and other issues. And this is one part actually. Have you looked to these some kind of other vulnerabilities methodologies to study the impacts of climate change on water resources and actually the data you used also for the precipitation and temperatures, and how you link with the IPCC scenarios? I mean the real data from the weather stations from different countries to come up with these results.
Okay,
Thank you.
Thank you. I hope Carol and Yahab, you have a few questions now to address, but before, maybe I want to see if Ziad, you want to add anything on Ziad? Yes. From Jordan, our big supporter on establishing the Climate Change Center. And thank you for the
good evening, everyone. I think the outcomes of this report, it's very important to our region and to our countries. And one of them is Jordan, which is I think we are facing a big problem, especially in water resources, and the affecting the land, the food security, the agriculture, and everything. And I think this is a good framework to work on for the next, for the UNESCWA to help the countries how to take measures to avoid the results of that. And I think the picture, it's not promising, and this is going to be difficult facing our countries. And I think what I'd like to see, what kind of measures that the countries like Jordan and the others should be take for to avoid like the scarcity of water and this is going to be, I think, a severe pressure on our food security, and this is also will affect the countries in achieving the sustainable development goals. And one of them is I think, goal number 2 and goal number 6 in this regard. Thank you, Aurora.
Thank you, Ziad. One last intervention from our
actually
colleague from Sudan.
I want
very
to add,
quickly.
I want to add that in Africa City of Technology, we have one of the largest computing platforms. It's almost like 16,000 core working together, giving a total computing power of 40 trillion operation per second. And we can have this available for the project. This would increase the accuracy of because we are speaking about climate modeling, then you are speaking about finite elements. So as much as finite elements you can have, then be better. Grid computing would be the best thing, and we have now doing it for Sudan. And now we are expanding it for IGAD region. So we have a couple of good scientists working on that, and we can have a joint operation here.
Thank you. Carol and Ihab, are you ready? Yes, please go ahead to respond, and then Carol, we will go straight into the second presentation.
Okay, thank you. I will try to cover some of the question. First, from our colleague from Sudan, it was a very good question, how to link time to the impact of climate on different sector like a crop. I guess we already started doing that, I mean, through, and this is what I mentioned, one of the important of RECAR output that it has this daily output data. So daily means the time, I mean, you have the data, the precipitation and temperature data available on a daily basis. So to study, I mean, how is the impact of climate change, you have to do the modeling. Now, modeling on the impact on the crop, on water, groundwater resource, on surface water resource. So now we have the climate data with this short time step. We can use the modeling to see the impact of this climate on different sectors. So it's through modeling. And for our colleagues, that recommendation to have RECAR 2, the crop yield sensitivity. Actually, we already started in RECAR 1 We are not waiting for Ricard 2 to do that. So, I mean, in Ricard 1, we have two projects almost. The first one, the one you already mentioned, is the output. This was study, I mean, FAO, GIZ, UNESCWA, and ACSAD. And there was 3 pilot area in Jordan and Lebanon and Egypt. We selected major crop. And now there is another project with UNESCWA, FAO, ACSAD, also funded by SIDA. And it's focused on capacity building of the country. So the country need to do this study on their own. So we're doing, the whole project is capacity building. We did series of training. And the country, we have 10 countries. I mean, 10 countries. I mean, we have Sudan, Iraq, Yemen, Jordan, Palestine, Tunisia, Egypt, Morocco, and Lebanon. Yeah, 10. So 10 countries, and every country has team. So we're doing the training for the team. Then the team will be trained. I mean, other people in the country. So they should be able to do this kind of study, the impact of climate change on the crop yield.
The simulation model, Mr. Ihab, the simulation model, do you know what variables were used?
Yeah. This I not finished. Yeah. So of course there is tens of models available. I mean, it's called the gross model. I mean, so there is DSAT and aquacrop. Of course, we selected aquacrop for different reasons, but one major reason, aquacrop is water-based model. This water-based model is linked directly the moisture to the yield, and it can take the climate data. So this is one of the major reasons we include this model, I mean, the study, and it's freely available. Anybody can download, and with a lot of support available on, so of course, major input, I mean, the climate data input, the crop parameter, like the phenology, and the soil and management, etc. All this input to the model. And for this, okay, I will not, for C3 and C4, we can discuss this later because it's a lot of technical.
It has a huge impact.
Yeah.
Conclusion, you're telling me I have to be happy.
Yes.
If CO2 levels
Yeah, actually, let me just, I will make comment on this. When we did the, yes, when we did the modeling, yes, when we do, first we get the modeling output the first time, I was shocked. I mean, I mentioned this several times, how CO2 has impact on the yield, actually. Climate change is something good, not bad, I mean, when you have the water. But if you don't have water in the soil, CO2 will not have positive. I mean, CO2 have positive impact only if you have enough moisture in the soil. This is very important. Second thing, let me mention, after we did this was until 2010. Then we decided not to talk about the crop, the impact of climate crop beyond 2050. I mean, because beyond 2050, I mean, when CO2 expected to be more than the concentration, more than 500 ppm, really there is not a lot of field study and lab study the impact of CO2 more than 500. So now, in our new project, we decided to do it only until 2050, where the concentration about 500 ppm. So,
Mazen, because of time constraints, let us keep, because I see that we need to have a long discussion on that subject, and that would be very interesting.
Okay.
Let Ihab finish, and then Carol, because we really need to close that session, to wrap up and close. Ihab,
okay, for our colleague
very
from
briefly.
Oman, I mean, if we look to another vulnerability study, I mean, actually we have partner from Europe, I mean, URAC. This, I mean, so we rely on URAC, I mean, their experience on Europe. So they were, I mean, our partner in this vulnerability study. I mean, and beside URAC, Edelphi, yeah. Edelphi also from Europe, where they were, the study you mentioned, we did not look, but we looked to other study in Europe, I mean, done. Of course, there was a lot of difference between Europe and our region, so we worked with them, I mean, together to get to this result. I mean, maybe you can.
Thank you, Ihab. Carol?
Yeah, no, there was a very extensive process for developing the methodology and fine-tuning it, the vulnerability assessment methodology in the regional context. We thought it would be faster to do that part than the impact assessment, you know, the supercomputer. We thought the 18 months it took to churn out the impact assessment projections, we thought, okay, vulnerability should be easy. It's just numbers and Excel, and you put it onto a map. It took us longer to do the VA than the supercomputer with the 18 months to generate the projections because we had a lot of fine-tuning to do. There were no harmonized data sets that could be used from Morocco to Oman to Somalia to the north of Iraq that could be consistent. And that's what really took a lot of time to generate those new maps after fine-tuning the methodology so that it was focused and the indicators were focused. So what I'd like to do is then just show you what you have available. There's a lot of slides, but I'm going to go very fast so you can just have a visual of what's happening. But basically, all the information in this publication, in these publications, in the publication series, and all the training materials that have been presented are available on a regional knowledge hub. We have been updating the website. You can now find it at www.ricard.org. And this website that has all the information that we are still uploading because we had to transfer it out of UNESCWA's website into a standalone, so we are uploading it as we go along, is also linked to a data portal that FAO is hosting and putting all the data files. And that's what I'm going to show you right now because we are a technology forum, so you can get a sense of the scale of information that you have now and your countries and your researchers have available. But on this Knowledge Hub, just to understand, again, we are under the auspices of the Arab Ministerial Water Council. They are our governing steering committee, let's say. ACSAT and UNESCWA are the coordinating secretariat with FAO as host of the data portal. And we have knowledge nodes with various additional information related to RICAR in other sectors, be it negotiations, the work of the meteorological centers through the Climate Outlook Forum, etc. And as I mentioned, there's a website that has the two-dimensional materials, and then a data portal that allows you to be able, later on, hopefully within the coming couple months, you'll be able to download all the data. If anybody wants data now, I have it, but it's half a terabyte. So it's something we need to send you on a separate disk. It's not just a Dropbox file. So this is the RICAR website. Again, it's live already. You can get some information there, and it's will be increasingly populated as we take it out of UNESCWA and put it on the standalone site. The data portal includes the climate modeling, the hydrological modeling, and the VA outputs, and links to all the partners and our colleagues at Cordex. Just to give you a sense of what we're talking about here, okay? And every little box you're going to see is a map. And every map has 6 data files, be it a ArcGIS file, the raster files, the data files, the different formats that you will see right now. So for just the climate modeling outputs, we're producing outputs at different scales, the 50-kilometer scale to the 25, and for different scenarios at 4.5 and 8.5. Each of those have different projections. So different projections, different models are used for each of those scenarios. If you take just one component, that RCP 8.5 at the 50, for the 3 models used, those are aggregated into an ensemble mean, because what we were saying, more is better, right? So I can't just take EC Earth, one projection output, and say this is the answer. The more projections that are generated into ensemble, the better. And our plan is to even do more. But a minimum of 3 is what we have for each of these outputs. Each of those are produced for the Arab, and all the subdomains you saw the little boxes for, right? And the mean is generated for the ensemble. After that, each of those are generated for the time periods that we are looking for. As Ihad mentioned, they are available on daily. They are generated 3 hourly for the century, but they are available daily, but we are just producing 20-year time steps until the end of the century, and that's again for each domain. Each of those are for a set of parameters, temperature, Tmax, precipitation, consecutive dry days, etc., with the seasonal component. As mentioned by our distinguished Dr. Osama from Sudan, the need to also think not only in terms of annual trends, but what it means for different seasons. And every country, every researcher can then break that down differently. We just had summer, winter, but maybe someone wants to do different months or quarterly or whatever. You can generate that once you have that data, that daily data available. all that for each of the models. So each of these little spots is another data set and another map that is generated. And it multiplies depending on what you are talking about, scale, ensembles, and the projections, okay? So each of those has your map, your netcdf file, which is the computer modeling language, and the two-dimensional map. This then is fed into hydrological models. Again, different scales of analysis. We take one. 3 different models were used because you cannot combine HYPE outputs with VIC outputs or HEC HMS. These are different types of water models. So different outputs, 3 different models coming out so you can compare across these different types of structures. Each of those come out, again, different projections. I'm just going quickly just to give you a sense. All those different time periods for the ensemble. Just for one example, HYPE. HYPE has a set of projections that come out for water. Each of those boxes is something. VIC generates another type of set of indicators, again, runoff, ET, etc. HEC HMS generates even more parameters. All that is available for agronomists, for modelers to look at floods, agriculture, impacts on health, etc. And all that is then multiplied, come in for each model, and all these are data points that you can do for the different time periods or series. Again, all the different available time structures for that information is available. You take all that and we identify the most key parameters of interest, and that's when we put into the vulnerability assessment. So just to give a sense, we looked at a total of 80 exposure indicators came out of the modeling to feed in. 25 indicators related to population, nature, man-made effects, and 26 categories and 27 indicators used to inform adaptive capacity. And all those, again, maps, fact sheets, Excel sheets, everything is available so anyone can take that, update it, apply it, take the parts that they want for their sub-region or country to move forward. So everyone there, again, 6 file formats. And that is available for the 9 sectors analyzed. I'm just going through. So each of these numerical value-based maps and classified maps used for the vulnerability for the aggregation, again, available. And you can't even see this at all then, just to give you a sense of the quantity. Okay, so all this has been transferred to FAO. They have all the impact assessments ready. They're still working on the vulnerability assessment. You can download, you can access, you can have the information available. If someone wants to do research now, we can send it to you. So it's just a matter of advising what you need and being more specific, because you can't just say, I want everything from X year. It doesn't work. You need always ranges. So, but we can provide that for you. And then also you'll be able to get the facts and the information as to where that information came from. So as the closing slide now, as mentioned by Rola, we have now this huge set of data at the Arab regional level. We have already started working as to the so what of these climate data, how it is impacting more specifically crop productivity, how it's affecting health, how it's affecting shared water basins. But in the end, RICAR, though everyone talks largely about RICAR, is a scientific assessment. It does not get into the so what side. And that is why RICAR, where we're going to do more work on creating bias-corrected projections that can be used for water resource modeling, capacity building to help researchers and governments use the information, and increase the science base available for forecasting and linking that with disaster risk reduction and climate change. That's the science. That's the empirical studies that supercomputer. Any type of modeling. But we need to bring that into the science, into the policy sphere, and that's where I think a lot of you are very interested to take that and figure out that so what. And that's what that Arab Climate Change Policy Center that we have been discussing for the last few days, and that was requested by member states, is bringing that into what that means for negotiations, what that means for SDGs, what that means for different policies. And those are those 5 pillars of work identified in the Climate Change Policy Center that will draw on the scientific base of RICAR, but is definitely not the same. RICAR is science. The center will then take that and do the so what. And with that, we open up maybe for questions. Thank you.
Thank you. I think we're getting to, we're running late. Are there any burning questions or comments? Leah, تفضلي.
Yeah, I know we're running late, but just a suggestion. A couple of months ago, the Union for Mediterranean established MEDEC, a Mediterranean experts on environmental and climate change. And it's just like the IPCC, but for the Mediterranean region. So I think it's very, very important at this stage to mainstream the results of the RICAR, because what they are doing, they will do the first assessment report for the Mediterranean region. So for all the countries, UNESCWA member countries that are also part of UFM or part of the Mediterranean, it's very important as experts, as scientists, to be part of the MEDEC so that that their results and their research is mainstreamed at an even larger level, and that RICAR, so you as owners of RICAR, maybe get in touch with also the MEDEC to influence this Mediterranean, so that our the Arab part of the Mediterranean has an equal share of input as the northern part of the Mediterranean. So let's try to do this and have a louder voice altogether, also at the Mediterranean level.
That's an excellent suggestion. Carol, are you aware of this MEDEX?
I am, and the thing, we've talked many times to the MED people. The MED, they have their own domain. We've presented several times RICAR to them at UFM. There's always this little bit of, actually it was because of them that we had to call MENA in the global, not Arab. Just so you realize a little bit of the storyline behind the Mediterranean versus the Arab. Though we cover certain areas, we still say Arab, and they definitely say Mediterranean for a very specific region. And they don't cover a lot of our countries. But that said, they're very familiar. The Greeks are very aware of what we're doing, and the Italians. But the communication should be stronger, and we're familiar with that technical group. Thank you.
So maybe as member states, not as UNESCWA, we can put the pressure on the UFM and on the MEDEC to take more of this into account as member states. So just to
excellent suggestion. Yeah, we're taking notes. I think Marie-Thérèse, you're taking notes, right? Our colleague from Oman, please.
Countries, and also what's the time frame in order to conduct or to to reach your targets from those 3 points? Thank you.
Carol, do you want to? Yeah.
We had a consultation just at the end of May with all the partners and several countries present. This is obviously for one PowerPoint, but we have a proposal, and right now we're elaborating the concept note further based on that consultation, which will be circulated and further endorsed. We want to go through intergovernmental processes. This is the intention, but there's a lot there about the demand-driven requests. We're going to bias correct all the other projections that exist as a quick fix to get more projections available for researchers, because bias correction you need in order to do the so what impact assessments, and all we have right now a lot is, besides what we have, are the unbiased corrected outputs that only the climate, not the hydro and all this. So we're already starting on some things, but it will be for the countries also to ask what they want more, and then also to continue the Arab Climate Outlook forums and all this. We have more details, and we will circulate that as soon as it's consolidated and consulted, and we hope to have more feedback, because the more we fit in there what the requests are. And what I didn't show you, just because I want to stop here, is we have already some interest of some partner institutions. I'm looking at Sudan, that have expressed interest as new collaborators and research centers for this next phase. We need to know what those are, and you know, if there are specific centers. Egypt has already said we want, and you know, this is it. The Moroccans have also indicated that they want to be more active. So if there are centers that want to be more formal partners, not already we consult with the countries, but more formal partners, we of course want that as part of our proposal, because as you can see, the Climate Change Center is now XB per your requests. So we need the more assistance and collaboration to make this move forward over a next 6-year period. The time horizon is the next 6 years.
Thank you. Dr. Osama.
Yeah, I want to make a proposal of creating a research cluster. This is a perfect example of how we can give a good example of science to policy. It's perfect. UNESCWA is a governmental body, so it's a policy-making body. You need a cluster, a science cluster adjacent to it. So I propose that you have a science cluster, and then issues of research would be generated and sparked, and capacity building and all these things will be cared for by this cluster.
Yeah. Carol, do you want to tell them about one of the pillars of doing peer-reviewed articles and journals that
Yes, one of the components that we've are working with already, our colleagues in Sweden, the Swedish Hydrological Meteorological and Hydrological Institute, has already done with several African countries writing workshops so that they take data generated for, let's say, the Africa domain. They look at the outputs and generate peer-reviewed journal articles and help researchers in the area to do this. So you get a lot more in Africa in the assessment reports of the IPCC than you might for the Arab region or some of the Arab countries. So part of this will be to link up much more closely again with those research institutes to generate peer-reviewed literature, because if we are not writing and not getting in those journals, we are not present in those dialogues. So now we have a whole set of information. We don't have to depend on the global sources to have a collective view. And, let's say a country for Sudan, for example, you can use the Africa domain, you can use the Arab domain, you can have your national and have then even collective type works. I mean, there's different ways you can combine this. But anything that can draw upon at least this database combined with others, but at least this, we want to support as part of that process in order to build capacity, but also have the voice that goes out to that other part. And that's part of the core that we hope to be part of phase 2.
Thank you, Carol. If there is no more intervention, I know it's an ongoing discussion, and I know that we will be talking bilaterally with many of you. But the idea is really to introduce work that is building up, and that is really, we count on that type of partnership with all of you. Yesterday, for example, we talked with Osama about the possibility of having something on forestry with a number of countries that could build on these type of results, and then we could bring along Sudan, Lebanon, Morocco, Syria, Jordan to come up with proposals that would look at forestation, right? And that could be supported from the green funds, let's put it this way. With Oman, I know that there is a lot, and your minister today spoke about the extreme weather events, and you've suffered some of these, and I think Oman was really very pioneer in being one of the first, having one of the first environment ministries turned into environment and climate change, and looking at this as a, using technology in that sense to address climate change challenges. So again, we would like to partner with you, and we'd like to partner with all countries at sub-regional level, at national level, and also as a region, because I think there is a tremendous amount of work to be done. There is work for everyone and more. And I don't think the amount of work that needs to be done in terms of addressing climate change there's so much to be done. The most important thing is to have coherence and one voice. I think this is why when we look at so many different partners to be on board for the climate change, it's because we want to speak as an Arab region as one voice. Where are our challenges? And I thank Leah really for bringing up that part and say how we can tap into other types of regional grouping and influence to show the perspective of the Arab region. And I just want to draw on one of the examples that Carol gave, to put extreme weather event as 35 degrees What does it mean? For our region, we have every single day an extreme weather event. So really counting, looking at all the different scientific dimensions that influence the process from our perspective. This is what a project like RICAR has done, and we hope that in the next stage, looking at food security, looking at crop production, looking at that relation. I mean, food security is not just about climate change, but a big part of it is climate change. So thank you very much, and please, I don't want to, but I'm sorry, it's, yeah, please go ahead. On the contrary, we're happy. We could stay until 7 here. With Dr. Zahir. For sure. We've already promised Engineer Sulaimani that we will be part of this, but we will also be happy to disseminate this information. So, ladies, need to work on our website and disseminate this type of information. Thank you very much again. I think it's a pleasure working with all of you. Thank you, Carol, Ihab, for an excellent presentation. We look forward to continuing this work. And thanks to the translators, really. Always, we always appreciate the extra time you put in.